In this video, I'm going to walk you through a technique for assessing normality that involves creating a graph rather than using the empirical rule. All right, so we'll start off just by talking about this concept of a percentile. All right, so the first thing we do is we put the data in increasing order. All right, so all these data points are going from lowest to highest, so increasing order. And we rank each one of those data points. All right, so the first one has a rank of 1, then a rank of 2, and so on down the line. What we're going to do is find the percentile by taking the rank of the given number, right? So in this case, a rank of 2. Add to it the rank of the number that preceded it, so 2 plus 1, divide by 2. So we're finding the average of the rank of the number and the number that came before it. Divide by the total number of values in the set, and you end up with a percentile value. Right, so I'm just going to do the number crunching real quick. So we got 3 over 2 times 9, so 1.5 times 9. Times 9, geez Louise. 1.5 divided by 9, it says it right there in front of me. 0.16, I'll say 167. And what we need to do is get the z-score that corresponds with that percentile rank. Right, so what we can do, there's a calculator shortcut. Go into the toolbox. I'm in the probability combinatorics menu, so let me just go back. This is where you would land if you were going into the toolbox for the first time. I'm going to go on down to probability. I'm going to select distributions. I'm going to select normal. All right. So what we're looking for is a z-score that corresponds with an area of 0.167. All right. So if I do a norm CDF, what that's going to give me is the area having already known what the z-score is. What I want instead is the inverse norm, right? So you put in the area value, area, probability, percentages, they tend to go hand in hand. So I'm going to select this one, type in the 0.167. The mean and standard deviation are assumed to be a 0 and a 1 when dealing with a normal distribution, standard normal distribution, which is what we're looking at here. Hit OK, and it'll give me a value that I could round, so negative 0.966. And I could show you really quickly for the previous one. Just replace that with a 0.556, and you see it returns to negative 1.59, really negative 1.593 to keep with our rounding approach to things. So the next one will be 3 plus 2 divided by 2 divided by 9. So 5 over 2 is 2.5. So we went from, this is really 1/2, then 1.5, now 2.5, so we have a trend there. So I'm going to say 2.5 divided by 9. That gives us this number here. All right. But since I'm about to take this number and put it into this calculation, it kind of begs the question, why not just put in the 2.5 over 9? Then I can just edit this repeatedly. All right, so 2.5 over 9 with a 0 and 1 for the assumed mean and standard deviation is going to give me negative 0.589. And again, so the next one would be 4 plus 2 over 2, which is, 4 plus 3 over 2. Yeesh. That's 7 over 2, which is 3.5. So I can just make this 2 into a 3. All right, so negative 0.282. All right, do it again with a 4, 4.5. gives an even 0. Do it again. Up and over, change the 4 to a 5, so 5.5, 0.283. Then a 6, 0.589. Notice the trend here. It's all the same values that we already had, just in the reverse order and negated. So 0.966 and 1.593. All right, so then I just have to graph. I'm going to graph the original data point. So these values here against these values here. So ordered pair, first one would be 24.9, and then about negative 1.59, negative 1.6, so 24.9. All right, so this is 21, 22, 23, 24. So 24.9, and then about a negative 1.6, roughly. Then 28.5 and a little bit shy of negative 1. So here's 28, 28.5, a little bit shy of negative 1, put me about right there. 29.4 and a little bit more than half a unit down. So here's 29, so 29.4 is about right there, a little bit more than half a unit down. Negative 0.282 along with 32.1. So this neighborhood here, 33 right on the line. 36.2, so here's 36, a little bit after that, and pretty close to the line. All right, so, oh, I missed the 33.4. Let me go back and do that. So 1, 2, 3, a little bit, so like in this neighborhood here, a quarter of a unit up, and then 36.2, like around here, a little bit more than half a unit up. 36, 7, 8, here's 38, so we want 38.1, just shy of 1 unit up, and then 40.2, and that's going to be a little bit more than 1.5 units up. And so that would be the normal probability plot, all right? The closer the normal probability plot is to linear, the closer the original data set is to being normally distributed. So the closer the normal probability plot is to linear, so to forming a straight line, the closer the original data set is to being normally distributed. All right, and I'm just going to chuck this into a calculator real quick, clear out the stuff that I have here, confirm, type in the values, 24.9, 28.5, 29.4, 32.1, right, 32.1, 33 even, 33.4, 36.2, 38.1, and then 40.2. All right, hopefully I typed that all in correctly. All in correctly, right? Not what it sounded like. So I'm going to go down to normal probability plot, hit OK, and you can see that it gives us a baseline, but it also gives us the points that we just generated by hand. So if I hit the left arrow here, I'll get down to that first one, 24.9, expected z-score, negative 1.593. All right, negative 0.967, and so on. All right, I wrote 966. I guess it was supposed to be 967. Let me just double check that. 966 is what I got. Oh, because I rounded the .167. Okay, so they're both good enough. All right, and there we go.